Welcome everyone. I'm Michael Muldoon, Product Development Director at AV&R. We're here today at AV&R, specifically in our workshop, to kick off the inauguration of the 3M-AV&R Robotic Finishing Lab. It's a lab that we put together in collaboration to advance the field of robotic finishing in abrasives, and we're really excited to be here today. Unfortunately, due to circumstances, it has to be a virtual tour, so I've got a pair of HoloLens, and we're going to walk through and meet a few people. Let's go. Here's our CEO, Jean-François Dupont. Hi, Jean-François.
Bonjour, Michael, and hello to everyone who are following us on YouTube. We have customers and partners working with us in many countries, and we are excited to do this virtual event with all of you. In recent months, 3M and AV&R started a long-term collaboration. As market leaders in abrasive products and robotic finishing and inspection respectively, we want to pool our expertise to advance current technologies. As you know, AV&R is a preferred robotic system integrator for 3M, and our common ambition is to create synergy to advance the development of robotic finishing technologies in the manufacturing operations. The 3M AV&R Robotics Lab will be a privileged area at AV&R to test new 3M abrasive processes and products. The research and development that will be done here will allow us to propose technological innovation that will meet the current and future needs of the manufacturing industry. Ce laboratoire 3M est une première au Canada et nous en sommes très fiers. Le futur du secteur manufacturier va reposer sur les concepts de l'automatisation, l'intelligence artificielle, l'industrie 4.0 et évidemment la robotique. Chez AV&R, notre mission est d'humaniser la robotique et nous croyons fermement que cette collaboration avec 3M nous permettra plus que jamais de contribuer de façon importante à cette mission en offrant des solutions robotiques encore plus efficaces, flexibles, intelligentes et faciles d'utilisation.
Thank you, Jean-François. 3M is here with us virtually for the inauguration of the 3M AV&R Lab. We have with us today Debarati Sen, the Vice President of Global Abrasive Systems Division of 3M, here to help us kick off this great day in the inauguration of the 3M AV&R Lab. Hi, Deba. How are you today?
I'm doing great. Thank you, Michael. Thank you for including us. Excited to be with you on this incredible occasion. Really excited to be a part of the ceremony, albeit virtual. Maybe a couple comments from my side on this occasion. We at 3M have been really energized with the demand and growth we have seen and continue to see in robotics and automation. In particular, the need that our customers have for access to more experienced and qualified integrators and technical resources also from our side. I'm very energized today with the inauguration of the new AV&R Robotic Material Removal Lab in cooperation and collaboration with us. In particular, the appetite that we are seeing with our customers, especially in the current times as they're looking for more support for supply chain re-engineering, for more onshoring. This will require focused effort from leading players such as yourselves and us. So I'm very energized with what we can do, helping our customers, helping develop the market with the significant demand that we see coming our way. I really like how the lab has come together. It's very much hands-on and it's very real. So once again, thank you, Michael and Jean-François, for this collaboration with 3M. And from our side, we're really looking forward to working together, helping our customers succeed, helping our customers solve their most pressing problems. I would also like to take this opportunity to introduce Carl Doeksen, our global leader for robotics and automation. And maybe Carl, if you don't mind, please add a couple of thoughts from your side.
Hey, thanks, Deba. Equally excited to be here in a hologram. This is in a way, this is really cool. Although I do wish we could be there in person. Just two things from my side. Number one, AV&R's legacy is strengthened the precision aerospace business. It's just set, together. We know we can win in aerospace. We can win in any type of metalworking. Aerospace is such a demanding environment, and we're really excited about working with diversify, and we see that already in some of the medical implant work that we've been doing already. And secondly, these robots here in the new lab, they're not showroom robots. It's not, you know, green button, red button, you know, and shadow the part. These are real sparks to run real parts for real customers. And we're, again, excited to getting lots of parts in here to process and do proof of concept for the customers in Canada. So with that, I'll just turn it back to you, Michael. Thank you so much.
Thank you, Carl. Really appreciate your guys' input, and it's been a great partnership or a great collaboration accumulating in this day. Our teams have been working hard, although remotely, and it's you know, we've gotten to know each other even more working through these creative technologies. With that, I'm going to kick it over to Jean-François and back to Deba. I'll switch back over to Deba, and we'll have the official ribbon cutting ceremony.
Thank you, Debat and Carl. Dans chaque inauguration digne de ce nom, il y a toujours la cérémonie où l'on coupe le ruban. Alors, en ce 29 octobre 2020, je déclare officiellement ouvert le laboratoire 3M-AV&R. Many thanks to 3M for this collaboration, which is just beginning. The 3M-AV&R Robotics Lab will be part of the continuity of robotic innovations that have marked the last decades and will mark the future.
To continue the inauguration, we will now show you the demonstrations of our systems on real parts.
For our first demo, we're going to talk with Guillaume Demore, our robotic finishing supervisor. Hi, Guillaume.
Hi.
What have you got set up for us?
So we have our BFX 200C, which is our flexible robotic finishing system. And right now we are working on a knee implant. So we are working on the box area, which is a hard to reach area. So we are using our belt sander to access this area. And let me start the demo so you can look at it. So this system is equipped with many polishing motors as well as a force sensor. So we are working in the area using a contact arm, and the system is working with Trizac belts, which is a 3M standard product.
The BFX 200C, have we used it anywhere else besides the medical?
Yes, it's a proven system that is working in the aerospace area. So we are working on blades, turbine blades, on profiling the turbine blade, polishing the surface, and polishing the root of the blade.
Well, let me take a closer look. So right now it's working in the box area. Are you also going into the radiuses?
Yeah, we also use a different configuration to polish the cam area. So right now it's working on the flat surfaces, and we are using a platen to polish this surface.
I can see all the dust coming off.
And maybe, Michael, you can look at the HMI to see that we are also able to fine-tune the parameters on the program to adjust the feed rate. So we are able to remove a little bit more material in the corner here. So by using our graphical interface, we can fine-tune those parameters easily.
How many control points do you have?
Here we have maybe 300 points. Those program has been made using our software.
That's a lot of control points. Is it easy to touch up each one?
Yeah, you can, right now since it's running, I cannot change the parameters, but you can use the mouse to select multiple points at the same time. So you'll see after this operation that the belt sander is pivoting. So to access the different surfaces, we are able to pivot the belt sander and to work with the robot in its ideal configuration.
I see a few spindles and wheels. Are we using any of those for this process?
For now, we are not using the spindle, but there are other applications that could be useful. We could work on edges or the condyle using polishing wheels to increase or improve the surface finish.
There's a lot of inspection devices here, Guillaume.
Yes, these inspection devices can be used to measure either diameters, thicknesses, and profile. So right now we are also doing some trials on hip stem implants to measure different diameters.
How has it been interacting with customers in the lab setting? Have they appreciated getting feedback on the feasibility of their parts?
Yes, for sure. We have also worked with 3M to get the right abrasive sequence and the right product. So we are looking toward increasing the cycle time or decreasing the cycle time.
Great. That's fantastic, Guillaume. Thank you for the tour. Much appreciated. Okay, our next demo here is going to be with Matthew Chenard, who heads up our visual inspection team, and it will be the CRX with our automated visual inspection technology. So let's go. Hi, Matthew. How are you doing today?
Just fine, and you?
Great. So what do you have for us?
Here it's a demonstration of visual inspection, which is obviously automated. We're trying to inspect a prosthetic part, in this case a knee, which is a very shiny surface. We're trying to find any cosmetic damage on it. It could be a dent or a scratch, any handling damage like that. But we're also looking for any polishing defects or surface finish defects, such as a missing polished surface or over-grinded surface, anything that doesn't look right.
Now, traditionally, we do systems with the typical yellow FANUC robot. What advantage does the CRX bring to visual inspection?
Well, with the traditional robot, it has to be in a cage. It has to be protected. This one, as you can see, I can move around it. It's perfectly safe. And basically, there's less material being needed. I mean, in this case, I only have a light, a camera, and the robot. And also, you can imagine that I can work next to it. I can drop parts here. The robot could pick it up and inspect it. And we can imagine a scenario where the robot would need immediate attention on a part. Let's say it finds something, it doesn't know what it is here. It could present it to me. I could have a look at it and interact with the software and correct the situation if needed. So that's all the kind of things we can do here. It's a much more minimalistic setup and could be really interesting for some people.
So can I get in close as you run it?
Absolutely. As you can see, I've been standing next to it, so it's perfectly safe for you to go there.
What happens if I touch it?
It's gonna stop,
Yeah?
and you don't have to touch a lot. That's it, you're done.
It stopped. And now I saw it move, so now I can move it out of the way. Oh, that's great. Great, Matthew. Thank you for the fantastic demo.
Thank you.
This demonstration with the C-Arts FANUC robot represents very well the vision and the ambitions of the 3M-AV&R Robotics Lab, which is testing new technologies for our customers. We have asked our longtime partner FANUC to be part of this opening.
Thank you, Michael. And thank you to everyone who has joined this event. I'm Peter Fitzgerald. I'm responsible for our FANUC operations in Canada, Mexico, and South America. I'm connecting from our Canadian headquarters in Mississauga, Ontario, and while the pandemic makes it difficult for us to be there in person, it is a great privilege for us to celebrate with you the opening of this lab. At FANUC, we provide factory automation, including industrial robots, CNCs, and robo-machines. With over 25 million machines installed worldwide, we are recognized as a global leader. In Canada, for more than 30 years, we've made long-standing investments in our operations, including offices in Ontario and Quebec. We are here with people and facilities to support. When we started in Canada, back in the 80s, robotics was still very new to many industries, and our mission was to develop and support the market directly as an automation systems provider. As the market evolved and as industry embraced advanced manufacturing technology, we established select strategic relationships with companies that were recognized as automation leaders in their field. We're proud to say that AV&R is one of those companies. From the onset, 25 years ago with us, AV&R's highly skilled engineering staff pushed the technology envelope, delivering world-leading solutions to customers both here in Canada and abroad. AV&R is truly a great example of the outstanding skill and knowledge that Canadians can bring and that enables Canada to compete on a global stage. FANUC Corporation in Japan has recognized AV&R as a global surface finishing and vision inspection specialist, an achievement that is awarded to very few. AV&R's steady investment in R&D and investment in their showcase facilities, including a FANUC robot on display to the Highway 30, and investment such as this lab clearly demonstrates their commitment to their customers and their industry. We're excited to see the 3M investment in Canada and their partnership with AV&R for this lab. 3M is also a very important relationship for us at FANUC. Both companies are leaders in their sectors, and this kind of joint initiative will continue to advance finishing technologies and automation together. With that, I'd like to turn to my colleague Jim Cooper to say a few words from our North American headquarters in Rochester Hills, Michigan. Jim?
Hello, my name is James Cooper with FANUC America. I'm the Global Key Account Manager here at FANUC for 3M, and I just want to take this opportunity to congratulate 3M and AV&R on the opening of the new Robotics Lab. It's a really exciting time, and when we look at the use of robots in finishing applications, the relationship between the robot company, the systems integrator, and the media provider is really key to a successful solution. And in this case, the long experience that AV&R has with deploying robots into finishing applications, and then certainly the great length of time that 3M has been providing abrasives to the market, we think is just a great synergy between all the companies to come together to look at how to advance finishing solutions for the customer. So again, congratulations 3M and AV&R, and we appreciate all of your support and relationship and exciting times with the opening of the new lab. Thank you.
Thank you, Jim. From all of us here at FANUC, our sincere congratulations to AV&R and 3M on the opening of this lab. Thank you for letting us be part of today, and thank you for letting us be part of the work ahead. Stay well, everyone.
Okay, so now we're going to have a demo of our 2D and 3D inspection system inside of one of our, I guess we can call it our traditional cells. It's really built for speed and to inspect a lot of parts. Hi, Laurence.
Hi.
Mind starting it up for us?
Yes.
So Matthew, you mind walking us through the demo as the robot starts?
Yes, of course. So this is a traditional cell for us with a traditional robot. What you see here is a demonstration cell. This is why we only have one part. We don't have a drawer or tray, which would be added to a production cell, obviously.
So is a person allowed inside of the system?
Oh no! You see the robot moving right now, would be a really bad idea to be there. That's why I'm holding right now the e-stop and the teach pendant. What we have in this cell is our classical inspection setup for inspecting with a camera. So as you can see, you see lights moving right now. It's because we're always going to take multiple images for each point of view we're looking at. This will allow us to detect much smaller defects. Once again, we're looking at surface defects. In this example, we're looking at dents, so small depression in the surface. And we're doing that by taking multiple images and then reconstructing what we call a curvature using photometric stereo technology.
Now what type of part is that?
This is an LPT, so it goes into an engine airplane. Those blades need to be inspected by usually a human inspector, and they need to find a defect pretty small. It's much under the 1 millimeter range. And this is why this kind of cell will be able to detect much smaller defects, but most importantly, it's going to be much more repeatable. It means that we're going to detect always the same type of defect every day, every time of day.
So what's the difference between 2D inspection and 3D inspection?
Well, the main thing is that with 2D, you don't get the depth. You don't get the whole form. You get a profile of what's happening on the blade. Obviously, when we use photometric stereo, we get an idea. If there's a depth or not, we know it with photometric stereo. But we don't know what the depth is. This is why once we find something that looks like it has depth and it's a problem, then we're going to confirm that by going onto this 3D scanner here and get the area we're interested in 3D. And then we'll try to detect the defect once again, but we'll detect it in 3D. Once you detect a defect in 3D, then obviously you're going to get the depth. You're going to get all the characteristics you need to see if your blade is good or not. Or it can be repaired, of course.
So right now it's doing the 3D inspection.
Exactly.
Looking for the shape of any defects it found.
Exactly.
The blue light is the acquisition happening?
Yeah, blue light will be acquisition happening. So this technology used projector, which will project the pattern. And this pattern will be captured by, in this case, 2 cameras at the same time. And with that, this technology is able to reconstruct a 3D image of the surface. It can be quite fast. A bit slower than a camera acquisition because obviously you need to take more than one image, you need to take maybe more than one pattern, but still it takes a few seconds to take what you need. And like I said before, we won't inspect the whole part in 3D. We're just going to inspect the part we think is important because we would have inspected it all with the camera first to know which surface is important or not.
Yeah, this is a little faster than the CRX, isn't it?
It is. This is why you should. Normally you operate that with that door closed.
Okay, great. Now that the inspection is finished, Laurence, is there some results we can look at?
So here we found a vent in the 2D acquisition, and now we can look at it in 3D. So, as you can see, we have the depth of the defect.
Wow.
And also you can see that we localize defect. The red zone means that this is detected as a defect. Everything that is white is basically the shape of the blade, obviously, but it's not detected as a defect.
So now we can make decisions not only based upon the surface area, but the depth of a defect. It's fantastic. Okay. How about 2D inspection? Is our 2D inspection technology able to detect defects on these shiny knees?
On the shiny knees, yes. We won't use photometric stereo. It's not exactly working. We're going to use other techniques which will highlight defects with different type of lightings. Basically, the secret is in the lighting here. And yes, we'll be able to detect dents way under the millimeter, no problem. Scratches, also we're pretty sensible to it. We detect much more than needed, but obviously we filter them. And also we're able to detect surface finish defects, such as a missing polish surface, something that is badly grinded, anything that doesn't look shiny and perfect as it should be.
Great. So thank you, you two. This has been fantastic.
Thank you, Michael.
Okay, for our next demo, we're going to speak with Elizabeth Martel, one of our robotic finishing experts. Hi, Elizabeth.
Hi, Michael.
What do you have for us?
I have a collaborative robot that I'm currently using to create this buffing process on this part here. And why don't I show you a bit how I do it?
Is this, if I remember right, this is the first collaborative FANUC CRX robot in Canada production, and we happen to be the first integrator to get our hands on it.
That is correct. I'm pretty excited about that fact, I must admit.
So show us some of the cool things it's got.
All right, well, first part is the hand teaching. So I just exhibit here, perfect. It's here. So as you can see, the light is flashing there. So that means the robot is in a mode where I can move it around wherever I need to start it on my part. So with buffing, I'll start in a corner, maybe right over here. I'll orient my air in the right direction. See if I'm touching my surface. That looks pretty good. So then I can go over here and add this as a new point to my program, or the start of my program. And then I can move along, all along my part, adding those different points.
Great. And I see you have some 3M abrasives on the table. Have you been working with 3M to develop this process?
Exactly. It's what we're going to be putting on the pad here to create this abrasion all along the part and bring it to a very nice and shiny finish.
Great. Looking forward to see it run. Can you start it up?
Of course. Let me get to it.
So for the easy teaching, does it also allow you to, if you had the force for the contact or the process enabled, does the easy teaching address the force as well?
Yes, it's definitely a feature that can be used, added, and then more control. Especially in this application, being able to control, give it a constant force is very important. And then through the different programming I can do, I can also have a constant speed of my robot. Therefore, really controlling a lot of the aspect of this process.
We're really looking forward to working with Fennec, 3M, yourself, and some customers to put these collaborative robots into production.
Of course, it was my pleasure.
We are also happy to include our partners into this new project. Thanks to their expertise, they will help us develop robotic finishing applications in the 3M-AV&R Robotics Lab.
So, Robotics is a global leader in the development and sale of flexible and intelligent robot elements and offers top-class competence in sensitive automation. With the patented active compliant technology, short ACT, the company provides versatile solutions which with robots develop a sense of touch for every conceivable task of surface treatment, like, for example, sanding, grinding, polishing, or deburring. Thereby, ACT optimized robots intelligently adapt to even complex surfaces and automatically control their force. We are proud to have globally numerous leaders in the field of automotive, aerospace, and general industry as our customers. So, long-term relationships through collaboration is what we strive for. Our relationship with AV&R goes back to 2016 when Robotics entered the North American market. Being both world-leading companies, our relationship has grown and strengthened since our first meetings through all the projects we have worked on together. Together, we recently launched the AV&R BFX 500, where we created a new belt sander featuring Robotics ACT and patented belt sander technology. And the mission continues. At this point, we are working on the next generation of tools and equipment, which I'm sure we can present to you shortly. Robotics' motto is perfection is achieved when we strive for excellence, and AV&R definitely lives up to this. Creating new standard needs a lab with excellent expertise and equipment. It's similar to racing. The best car is nothing without the best driver. Neither can the best driver achieve records without the best car. You bring both together and you set new standards for the industry. In this lab constellation, manufacturers have the possibility to establish their processes, see what's possible, and create the next generation of products. It's always better to be one step ahead than one behind. Yeah, we continue our trustworthy relationship and partnership with AV&R and grow together even closer. As mentioned before, we are working on the next generation of tools, which are super flexible, extreme sensitive, and the easiest to use on the markets. Those will be the next game changer in the industry of aerospace and medical implants. But as well for heavy applications like weld grinding, it will change the approach and the demand on cycle time and quality. Robotics listens closely to the needs of the industry partners and customers. AV&R is one of our partners, providing us with valuable market feedback and getting new developed technologies in their hand first. In this constellation, we all can live up to Robotics' motto, perfection is achieved when we strive for excellence.
Hi, I'm Pascal Poitras from ProAx Technologies, a leading technical automation distributor in Canada that offers innovative product solutions in machine automation that is creating close relationships with our valued customers, vendors, and employees. We have been in the marketplace for over 55 years, and we continue to grow and expand our well-known products line and services to meet our customer needs. Currently, ProAx has over 180 employees with 14 locations coast to coast. Our key point of difference is our in-house technical solution team that allows us to provide solutions dedicated to customer-specific products or solution needs. I think this is a very good mission for our Canadian manufacturers that need some local expertise with AV&R and 3M in robotics finishing processes with a direct access to the lab for their needs. It will certainly benefit the manufacturers by having that lab with multiple robotic options from AV&R and multiple abrasives products from 3M. Proax has always helped with some key partners projects like this one at AV&R in the past and will continue to support and contribute to their successes. For this particular lab, Proax and Troax offer the overall fencing at a very special price to help them to creating that wonderful practical lab. Now that we know the mission of this unique lab in Canada, whenever we do have the demand from our customer that looking for that kind of expertise, we'll refer them to AV&R when this is possible.
Okay, we're here for our last demonstration today, and I've got Elizabeth Martel here helping to demonstrate, and I've also got Yves Proteau, co-president of APN, a special guest, who is we're actually doing customer trials in the lab. And Yves, welcome.
Thank you.
Yves, it'd be great if you could just give a little overview of some of the challenges you were facing and why you looked to robotics to solve your challenges.
Okay, our dream is to start to receive an order via internet and to deliver a part without touching it, to make all the process automatic. And since then, we implement ERP, we have MIS, we purchase CNC machine, we put robot on the CNC machine, we have inventory, automation, but the missing link for us was the polishing and deburring. And with that AV&R polishing machine, that's the missing link that we were waiting for.
Okay, great. And it's been interesting working through you with some of the different challenges. Maybe would you describe yourself as a high mix or low volume? What type of product mix?
It's more high mix, low to medium volume products mix.
So a key for you would be flexibility and being able to process many different part numbers and have flexibility.
Yeah, that's our main goal because for us, flexibility is important because we have to have not too big setup, because if we have a huge setup, it will be impossible to have a good ROI on the project. And with flexibility, that's important for us.
And some of our discussions previously, you talked a lot about what you've done with software in connected factory. How does this fit into your vision for the factory of the future and the connected factory?
In fact, with equipment like that, where you can connect the equipment to our system, that will link everything together. We were able to connect our CNC machine, our CMM, but when we go to manual polishing, it's quite difficult to connect the employees. And with the equipment like that, we will have the full process connected. And that's very important to have the right information, the process stability, because when you have employee, the other problem is to have the consistency, and when you have equipment like that and that type of technology, you can manage the consistency and be more confident with your quality.
Great. And Carl from 3M, when we talked with the 3M folks and we cut the ribbon for the lab, this space is really for performing actual trials and making chips. So we're really happy to have you part of our grand opening, and thank you for participating with us and allowing us to demonstrate a live process together.
Thank you. It was a pleasure for me, and in fact it was mainly a dream that happened, because we think that we are very close to fill the gap of the missing link that we have.
So without further ado, I'm happy we can do this virtually. It would be great to do it in person, but with technology, we're able to do some fun things virtually. And with that, Elizabeth, let's kick it over to you. If you could start the demo and we'll get to watch this together.
Would you like me to show you the second part or explain the gripper that allows for two different gripping of the part?
Sure, yeah, that'd be fantastic, Elizabeth.
All
If
right.
you could give us an overview of the gripping.
Definitely. So what you've just seen was the first part of the process, which uses the first hole in this gripper. And then in the second part of the process, we would have a flipper in the machine that would be able to then put the part and then grab it in the second section of the part to be able to access the full part in the machine. So I'll show you the second process, which is very similar, but grips it on the other side.
Sounds great. So when we start to develop processes, the first target is always quality. And then right after that, the next question is, how fast can this thing go? So Yves, I'm imagining in your operations that fine-tuning and the hitting quality, but doing it at optimal cycle times is probably top on your mind.
Yeah, it's top on our mind. And for us, is the stability, because when you have employee, you never know, quality could be different from the Monday to the Friday. And when you have automation, it's a lot easier to maintain that stability that the customer needs.
So now you're flipping the part manually. So in an automated system, this would all be done automatically?
Exactly. It would be in the cell, and you would just have to put it, and the robot would trot it down, come around, pick it on the other side. So yeah, it's definitely in the making.
Well, that's great. So, Yves, thank you so much for being part of our opening day. And, you know, we're well on the path to making your dream come true of a fully automated process. And this is the reason that we put this lab together in partnership with 3M and to bring value to customers like you.
Thank you.
The 3M-AV&R Robotics Lab visit is coming to an end. Jean-François, I'll leave you with the last word.
Thank you, Michael. We hope you had a good overview of the research and development opportunities of the 3M-AV&R Robotics Lab. As soon as possible, we'll be delighted to welcome you physically in the lab and to introduce you the new technology that will be developed there. Thanks to 3M for sharing this project with us.
So thank you to everyone here at AV&R for helping to put together these great demonstrations and building this lab. Thank you to our partners for joining us virtually. We hope to see you here soon in person. And of course, thank you to everyone for tuning in, listening to us. We'll see everyone online again shortly. Have a great day.